take a look at these two different problems where this is going to be the case. Okay? And it's important to see whether they give you this piece of information. If they tell you the leading coefficient is a plus or minus 1, all you need to do is use the multiplicities at the zeros, okay, to determine what the overall equation would be. So this is the easier of the two types of questions. Okay, so if I gave you that question, all right, so if we were doing something like that, what you would see is you have two zeros here. So when you have your zeros, those are associated with factors. So what factor is associated with this first zero? X minus 1. And here the next zero is x minus 4. If you had a 0 over in the negatives, it would be x minus a minus, so it would be x plus. So you know that you're going to have these two factors. Okay? We know our leading coefficient's either going to be positive or negative. So when you look at the end behavior, okay, they're going in opposite directions, which means the total degree should be what kind of a number, odd or even? Going opposite directions means odd, so we know it's going to be an odd degree. Okay, and what's the leading coefficient going to be? It goes up to the right, down to the left. So it's going to be a positive leading coefficient. Okay. So we know it's going to be a plus 1 for this case. So the last thing we need to do is based on the rules of the graph, we can identify the multiplicities. So this graph indicates a multiplicity of what? Passes straight through, so it's a multiplicity of 1. I can leave that unwritten. I'm going to enter it there just to demonstrate or verify. And then what's going to happen here at the 0 associated with this? The bounce indicates a multiplicity of 2. So what you get then is this equation. Again, leave out the power of 1. And if you enter this, you can leave it in this factored form. You will have your solution.